Good morning. Hello from beautiful Colorado Springs, Colorado. I want to talk to you this morning. I'm going to do them in chunks. I'm going to talk about 5 minutes a time, and we're going to get through chapter 6. So it's morning time. The sun is up. The mountains are behind me. It's so beautiful. It was about 17 degrees this morning. So it definitely got our heart rate up this morning. So I'm jumping in and I'm starting on page 116 in our book, and I'm talking about acute responses to our cardiovascular system whenever we engage in aerobic exercise. So the first thing that I want to talk about is cardiac output. We see cardiac output being the product of your stroke volume and your heart rate. Your stroke volume is the amount of blood pumped with each individual beat of your heart. So imagine your stroke volume like a giant sponge. And if you were able to go in and dip that sponge in a bucket of water and then squeeze it out, the more fit that aerobic athlete is, the better and the more efficient they will be at squeezing that ejection fraction, is what that's called, out of the heart. And the better the athlete does at training and the better program design the athlete has, the more efficient they will be and they will have a larger stroke volume. Another thing that starts to happen with stroke volume and heart rate is heart rate actually starts to go down. It becomes more efficient at a resting level. And that is actually called bradycardia, when we see an aerobic athlete having a lower resting heart rate and a lower systolic and diastolic blood pressure as well. And we actually start to see, as far as oxygen uptake, the maximum oxygen uptake that the body can be used at the cellular level expresses how efficient the aerobic athlete can be at utilizing cardiac output and maximum oxygen uptake for the duration of that event. On the top of page 117, we actually see this formula called the Carbonin method of determining maximum heart rate, and we see it as 220 minus the age of the athlete. That maximum number that you see, that would basically be for your average person. You and I both know that when someone is very efficient and cardiovascularly fit, that they can take that maximum predicted heart rate up just a bit and still be in a safe level. But this is a great way for us to determine that safe heart rate zone for someone, especially if it's a novice. I'm going to recommend that they start off at about 60% of that maximum predicted heart rate and stay there in the beginning as we start to design programs. When we talk about blood pressure, it actually comes in two different phases. You have your systolic blood pressure and you have your diastolic blood pressure. Typical blood pressure, actually, when we talk about numbers, is typically systolic on the top, 120, and diastolic on the bottom, 80 or lower. We see that the systolic blood pressure is the pressure applied to the arterial walls as the blood is being pumped away from the heart. It's okay for this number to be a little bit higher because this is actually during the pumping phase. We get a little bit more concerned when that diastolic pressure is higher because that is the phase that the blood is not being pumped and we actually want the heart and the arterial walls to be resting just a bit. So knowing someone's blood pressure is kind of a great way to check in with their overall health of their arteries and veins. And if they're supple and soft, probably because of collagen content, we know that that will help that athlete be more efficient at delivering that work to those, that blood to those working muscles. So when we think about acute aerobic exercise results, and that's on page 118 in that box there, we see an increase in cardiac output, increase in stroke volume, an increase in heart rate, oxygen uptake, systolic blood pressure, and blood flow. We actually decrease diastolic blood pressure during that phase because the muscles actually act as a pump during that phase of the aerobic activity. It's interesting that we see these things going on. We see this thing called minute ventilation. I'm in the bottom left-hand corner of page 118. During minute ventilations, we actually see this is the volume of the air that is circulated during a 1 minute phase. And what's interesting that we see is while you're at rest, you typically only have about 12 to 15 breath cycles. But during maximum cardiovascular exercise, we can see up to 35 to 45 minute ventilations occurring while that athlete. That's a response to that athlete's need for extra oxygen being delivered to those working muscles. So on page 119, this is a great visual of what we actually see happening in the capillaries, heading to the pulmonary vein, through the atrium, back in, working in the muscles, coming back through the right atrium. This is a really good analogy of what happens, especially if that aerobic athlete is incredibly efficient at their program design. When we think about your opportunity to show off, on page 121, just like there was in chapter 5, there's a great chart of talking about things. We're going to see that muscular strength is really not going to change. Muscular strength doesn't change because of adaptations to aerobic training, because it's on the wrong side of the line. But we do actually see a change in mitochondrial density. We spoke about that last week when we were together. We actually see stored ATP. We actually can see an increase in ligament strength, tendon strength, collagen content, and that's variable because that's going to respond to the modality of the aerobic activity that the athlete is involved in. Again, we mentioned if our aerobic athlete is either cycling or swimming, we're not going to see those big changes in ligament strength and ligament content because of being non-weight bearing, and that's really important. We see these changes, and again, on page 120, that's when it talks about bradycardia. I already mentioned that, but I know you might want to see it in your book for your show-off opportunity. Lots of good information here. I know you're smart people, and I understand that you'll be able to already know most of those things going on that page. So come with me over to page 122, and you know that the first of all the systems to arrive on the scene to create change with any athlete is that nervous system. And on page 122, we see that the nervous system adaptations play a significant role in the early stages of aerobic changes. The body will respond to whatever you ask it to. So if you ask it to become more efficient at delivering that oxygen to the muscles, it really will. We see that the athlete that produces more efficient locomotion is going to be that athlete that crosses the line first. Over in this right-hand column, we see that this athlete, really and truly, that athlete that can delay that OBLA, remember that onset blood lactate accumulation, we can see them buffering off those hydrogen ion accumulations and actually being able to delay that so we don't end up with that lactic acid cranking through that blood and that hydrogen. That's an important thing to remember. And in the bottom right-hand corner of this, you all know all this, we see that there are changes that take place to the fiber type transition. And so whenever I have my aerobic athlete only aerobically training on the left-hand side of the line, we see those type 2X fibers actually migrating, and that makes that athlete less powerful but more aerobically efficient. But remember, we have to have our aerobic athletes training on both sides of the line for them to be the most efficient possible. We see myoglobin and the mitochondrial densities change. We know that's going to happen because those are both oxygen-rich content, and that's going to be a direct response to exposing the body to those aerobic demands. One more thing I want to talk about, and then I'm going to take a break on this one. We actually talk about bone and connective tissue. Bone and connective tissue are going to respond, especially if they're load-bearing, and we see that increase in cartilage, that increase in collagen. We also see that movements that are in the full range of motion on page 123, whenever we're seeing our athletes making those changes in that full range of motion, we can see them becoming more efficient with the tendon length, with the tendon strength, with the ligament connections, and all of those as they come together. So we're going to take a break right now. I'm going to come back and check in with you in a minute. So phase 1 is now complete. See you in a little bit. Bye.